Okay, YouTube, in our last video we focused on how to multiply polynomial functions, and that is kind of like what you see over here, these products that you see here. We want to find, say, 2x plus 7 times 2x minus 7. We should be able to do this. It's just that all of these three that you see over here, where we have 2x plus 7 times 2x minus 7, or say a binomial times itself, or a binomial times itself 3 times, these fall under kind of like special product patterns that we see often when we talk about factoring, or sometimes where we're unfactoring, where we're multiplying it back together. We just know the patterns that pop up. So they're worth knowing, and I want to visit these three patterns here. So the very first pattern you're going to see is the sum and difference pattern. And it essentially says that when you take a plus b times its conjugate, so I'm going to use this word here, conjugate pairs. And I just don't have a lot of room to write, so I put it over here. But I might write a little note here that a plus b and a minus b are what we refer to as conjugate pairs, because you get a sum and a difference that you're multiplying together. But every time you do this, you're going to get a times a minus ab plus ab, and then you're going to get minus b squared, which means your middle terms always cancel out, and you get this, what we call a difference of two squares. So the reason why it's worth noting is because when I have something like this over here, and I say, well, what's like my a and what's like my b? In this case, I would say my a value is kind of like the 2x thing, and my b value is like the 7 right here. And what we're getting is a plus b times a minus b, and what I know I get is a difference of squares. So when I multiply this out, I'm going to go ahead and say this right now. I know I get a difference of two squares, where this is usually like my a term and this is my b term, but in our particular case, we'd say I just get 2x squared minus 7 squared. And you know what? This, when we square, sorry, I got a little ahead of myself. I said 2x squared, and I wrote down 2x squared. This is 2x squared minus 7 squared. But when we do this here, 2x times 2x times itself is 4x squared. And then when we take the 7 times itself, we get 49. So this is easy to recognize that this just comes out to be that difference of squares right there, but also that it's easy to multiply them together if you know what your a part is and your b part is. So speaking of that, when we have a binomial squared or a binomial cubed. Okay, so let's talk about the square of a binomial. I know that when I take a binomial like a plus b times itself, what I end up with is a squared, again, a times itself, but then I get plus ab, so plus 2 of these ab things, and then minus b squared. And when I take a minus b times a minus b, I still get a squared in front. I still do, a squared, but then I get minus ab, which is minus 2 of these ab things, and then it's still plus a b squared, and this should be a plus here. But basically, you notice the only difference here is this middle term. So when we have a binomial that's being squared here, what this essentially says is a plus b squared or a minus b squared. You're going to get the squares on the outsides, but this middle term should always be twice this times this there if it's a perfect square of a binomial. So they give an example here. Y plus 4 squared would be y squared in front, 4 squared in back, but this middle term would just be twice our y times our 4, or 2 times 4 times y, which is our 8y. So what I'm going to do is I'm going to displace this down here. I say, well, 4y plus 3, we're squaring this binomial. And I know that in this case, my a thing here, like my a is 4y, and my b thing here is this 3. Okay. Oops. There we go, 4y. Getting the colors right here. So when I FOIL this out, we say a plus b squared. I'm going to get a squared plus 2ab plus b squared. Then what this means in our case is that I'm going to get a squared, which is our 4y squared, plus 2 times a times b, which is 2 times 4y times 3. So there's our a and b part, plus now our b squared thing, which is 3 squared. So simplifying this, what we end up with is 4y times 4y, which is 16y squared. And then we say 2 times 4 times 3 is 8 times 3 is 24. I get 24 times y plus 3 squared, which is 9. This would be the square of that binomial. So for our last pattern here, we have a plus b cubed. And one thing I'm going to point out is if we had taken a plus b cubed, which is a plus b times a plus b times a plus b, we already did a plus b times a plus b, and we know we get this here. So in this particular case, I get a squared plus 2 times a times b plus b squared times a plus b. And we can carry all of this out right here, but I'll tell you, looking at this pattern up here is going to make it a lot easier on us. We say when we cube a binomial, it is just the case that this is our a part and this is our b part. And what you get over here looks like this. So now the signs are different. We'll talk about this in our next video with binomial expansions. But basically when you cube a binomial, we're going to get the cube of the first thing and the cube of the last thing on the outsides. And then in the middle here, we're going to get 3 times a squared b plus 3 times ab squared. So when we look at this, and I hate that it's using an AB plus 2 cubed, but I'm going to block this off. What I'll do is this. We say, how about xy? I'll use an xy here plus 2 squared. I'm using this example right here, but I'm taking out the a and b because what I'm going to indicate here is that our a part is like this xy thing, and our b part of our binomial is like the 2. So that being said, I know that when I cube a binomial, a plus b cubed, I get the cubes on the outside, a cubed and b cubed. And then for this middle part, I can look back over here, but it looks like I get positive 3 a squared b plus positive 3 ab squared plus that last cube there. So when I look at this, I say, well, what am I going to get? I'm going to get a cubed plus 3a squared b plus 3ab squared plus b cubed. And we're just going to go put these values in here for a and b. So we say xy is like our a part, xy, and then our b part here is the 3. Now what we get to go back and do is simplify all of this. So xy times itself 3 times, that'd be xy times xy times xy would be x cubed, y cubed, plus now 3 times xy squared times 3. The 3 times the 3 give us a 9. xy times xy, that would give us x squared, y squared. So now over here we have 3 times x times y to the first times 3 squared. So 3 squared, let's do that first. We would get 9 times 3. So we'd have 27 is our coefficient, xy. And then 3 cubed is 3 times 3, which is 9 times 3 is 27. So we would say that this is our cubed binomial right here, and we just used our pattern to accomplish that. If we didn't know, what we could do, if we didn't remember this pattern, that is to say, just remember one last thing. You can certainly rewrite what you have right here. And just using the properties of multiplication, we could start by multiplying these two first, and then taking the answer we get times that right there, and still wind up with the same thing we got right here. It's just that this is going to be a whole lot quicker. Cheers.